All right, guys, we're back at it. We're starting out on example 9, but we're going to be talking a little bit about the limit of a power. So we have the limit as x approaches a of f of x gives us L, where n is a positive integer. Then, if we take this, we're able to rewrite our limit as such. So we're able to take this, this n, and we're able to find the limit right here of this entire portion and then raise that to the power of n. Okay, this is one of the rules that you guys are going to be using quite a bit. So with this right here, instead of plugging in 5 and then doing all this, one of the things we are able to do is rewrite this as the limit as x approaches 5 of 2x minus 7. And then we take everything here to the power of 3. So when we do this, we know here that we're able to substitute this 5 directly in for our x value. When we do that, we're going to get 10 minus 7, which is 3. So we have 3 cubed. Okay, 3 cubed is going to give us 27. What I'd like you guys to do, please go ahead and do checkpoint 9 for me. I'm going to give you a moment to do that. All right, then from here, the same idea applies when you have a root. So when we're using this, so you're going to take the limit as x approaches a of f of x, and it's going to give you L. And where n is a positive integer greater than or equal to 2. So if you're taking a look at this n right here, we're able to go ahead and take it and put it over the entire portion, then take the root of our limit. Okay, where is that going to be helpful? Right here, we're able to take this and rewrite it as the square root of the limit as x approaches negative 2 of 4x squared plus 5. Okay, what we're going to do is go ahead and plug in negative 2 for this, and we have the square root of 4 times negative 2 squared plus 5. Okay, when we do this, we're going to get the square root of 4 times times 4 plus 5, which is 16 plus 5, which is the square root of 21. I'd like you guys to please go ahead and do checkpoint 10 for me now. I'm going to give you a moment. All right. From here, guys, we're going to go ahead and take the limit of a quotient. This is where things are going to get a little interesting. This is where we are not just going to be substituting something in and finding a value for it. In this case, we're going to have to think about if the function's even defined at that point. So we're taking the limit as x approaches a of f of x, and that's equal to L. And you take the limit of g of x equals m, where m is not 0. This part right here is super important. M cannot be 0. If it is 0, what's going to happen is we have to do a few things. So with it, we're just going to be taking this entire thing, taking the limit of the top, limit of the bottom, and then dividing them. We're able to split it up that way. Okay, once again, it says provided that the limit of the denominator is not 0. So we're looking at this. If I plug in 1, I'm able to go ahead and rewrite this as the limit as x approaches 1 of x cubed minus 3x squared plus 7 divided by the limit as x approaches 1 of 2x minus 5. And what's going to happen is I'm going to go ahead and plug directly into this, and then I'm going to get my values for it. So if I plug in 1, I'm going to get 1 cubed minus 3 times 1 squared plus 7 all over 2 times 1 minus 5. So with this, I'm going to get 1 minus 3 plus 7 all over 2 minus 5. Okay, so from this, I'm going to get 7 minus 3 is 4, plus 1 is 5. I'm going to get 5 over negative 3, or negative 5/3. And there we go. We have our value. So the next thing that we're going to be doing, is please go ahead and do checkpoint 11 for me, guys. All right, and then the last portion of this is we're going to go ahead and take a look at this last part. And then this last part, am I there? No, I'm not. I'm off by 1. I'm sorry, guys. we're going to be using properties to find one-sided limits here, okay? So here we have a piecewise function. This piecewise function, f of x, it's defined where x is less than 2, and this is where x is greater than 2. So we have talked about this quite a bit, but the idea is the limit from the left has to be equal to the limit from the right. I'm not going to draw this out for you guys because it's not going to be drawn to scale. I could try to. But what's going to happen is when we're taking each of these values and we're plugging it in, this means the limit once again from the left. This means from the left. So which function's defined for everything that's less than 2? Well, that means we're going to be using this. So we're going to take the limit as x approaches 2 from the left of x squared plus 5. And when we go ahead and we plug in 2 to this, we're going to get 2 squared plus 5. And here I'm going to have 4 plus 5, which is equal to 9. Okay. For this to have a limit at 2, the limit from the left has to equal the limit from the right. So once again, this part means from the right. So we're looking at everything that's greater than 2. So we're taking the limit as x approaches 2 from the right of 3x plus 1. When I take this and I substitute in my 2, I'm going to get 3 times 2 plus 1, which is 6 plus 1, which is 7. These are not equal. So what this means is that the limit does not exist. This means this does not exist. This is DNE, or does not exist. And why is this case? Because, or since, the limit from the left does not equal the limit from the right. All right, so what don't you guys do? Please go ahead and do checkpoint 12 for me. I'm going to go ahead and give you guys a minute or so to do that. All right, now from here, this is the last case. This is going to be the case where we're either going to have to factor or figure out something to get rid of the issues in the denominator. Okay, so with this, what's going to happen is we're going to go ahead and factor in this case. So let's go ahead and see. If I were to plug in 3 here, 3 minus 3 is going to give me 0 in the denominator. So I can't just plug directly into it. So what I'm going to do is I'm going to see if I can factor the numerator. Okay, so I have x times x. I know that it's going to have to be negative, so one of these is negative, one of these is positive. Okay, I need 2 numbers that multiply to give me negative 6 and add to give me positive or negative 1. So is it going to be 3 and negative 2 or negative 3 and positive 2? Well, if they add together to give us negative 1, it has to be negative 3 and positive 2, all over x minus 3. So we're able to get rid of this portion right here, and we're able to call this a removable discontinuity because we're able to get rid of it here. This is called, once again, a removable discontinuity. And when we do this, we're going to go ahead and find that we have 3 plus 2, which is 5. So the limit does exist here. Okay, and we had a removable discontinuity at 3. All right. Why don't you guys please go ahead and do checkpoint 13 for me. We got one last one and then we're done, guys. All right, on to this last one. This is going to be one of your cases where when you plug in or substitute 0 for x, you're going to get 0 in the denominator. The only thing that we're going to be able to see here is we have this on the top, and we're going to have to go ahead and multiply by the conjugate to see if there's anything we can do to get rid of that 0 in the denominator. So the way you do this is you multiply by whatever's in front, 4 plus x, and then you change your sign of your second term, and you do the same thing over here, 4 plus x plus 2 outside of it. When we do this, we're going to have to think a little bit about distributing everything. And when we do that, you guys are going to find that our center is going to cancel, which is really nice. So we're going to get the square root of 4 plus x quantity squared And then what's going to happen is we're going to get 2 square root of 4 plus x minus 2 square root of 4 plus x minus 4. And what you guys should notice here is these cancel. On the bottom, when we're taking this and we're doing this and we're dividing, we're going to have x times that, and then we're going to have 2x. So we're going to have x square root of 4 plus x plus 2x. Or we can leave it out where we have our x in the front. When we do this, what's going to happen is our square root's going to cancel here, and we're going to be left with the limit as x approaches 0 of 4 plus x minus 4 all over. I'm going to go ahead and distribute this x back out in the denominator. So we're going to have x times the square root of 4 plus x plus 2. All I did here is I took the x's and factored them out to the very front. Okay, and when I do this, I'm going to be left with our 4's canceling, and I'm going to have the limit as x approaches 0 of x over x times the square root of 4 plus x plus 2. Okay, and with this, all I have to do is substitute in 0 now. Wait, there's one last thing. If you guys notice, we have an x on top and bottom, so those cancel, and we're left with a 1 in the numerator. So we have the limit as x approaches 0 of 1 over the square root of 4 plus x plus 2. What we're going to do is go ahead and substitute in our 0, and we're going to have 1 over the square root of 4 plus 2. Square root of 4 is 2, so we have 1 over 2 plus 2, or 1/4. Okay. I want you guys to please take your time, work through checkpoint 14. If you guys don't have any concerns on this, please just send me a picture of checkpoint 14. I need that to see that you guys are working through the notes.